All right, let's get started. I want to thank you guys for coming to spend some time with us. What I want to do in this talk is basically talk about what we did with Knative, specifically the use case that we call Store Locator. My name is Gopinathan. I'm a full stack engineer with 22 plus years of software development experience. I'm a Golang and Java developer. If it's not obvious, I work for T-Mobile. So just to level set a few things, this talk is not about what Knative is and all the features. It's just simply to talk about a use case that we picked, a real-world enterprise use case that we picked as we went through the journey of test driving Knative features way back in summer. What I want to do next is basically just kind of go over like our motivation. Why did we start looking into Knative? So next few slides, I'm going to take some time to kind of give you guys a context. So before I do that, as a team, we are at a higher level without going too deep into the details. There's like two category of teams that we have in our company. One is platform service providers. What they do is they manage and operate platforms that our enterprise workloads runs on. We have both platform service providers for workloads that run on premises and in the cloud as well. And we run pretty much our work on all three clouds for a variety of reasons, which I won't go too deep into. And then the second class of category of groups that I call enterprise developers. What they do is they build and ship products that are used by our customers. So a few examples include our website, tmobile.com, our mobile apps that customers use, both Android, iOS, and other platforms as well. We also have an app called T-Mobile Tuesdays. And then there's a bunch of microservices that powers all those experiences, right? So at a higher level, that's kind of the two category of teams that we have. So what I want to do here is just kind of briefly touch on what our enterprise developers need. Most of this is pretty much shouldn't be a surprise to anyone here. Basically, they want to focus on writing the business logic. They don't want to learn about how to run the Kubernetes infrastructure, how to operate it. They want to, you have your source code in your repository. You want to be able to get, as I commit changes to it, you want to be able to get that source code built and deployed onto the cluster in a reliable and consistent manner. They also want to ship code to production faster. I think this is pretty obvious, right? If we don't do it fast, someone else will do it. So it's kind of a part of our digital transformation goal as well, to be able to deliver more features, solve customer pain points faster as much as possible. And then the last bit is observability. So we have this principle where if we put something in production, we call it we build it, we own it. You have to operationally be responsible for making sure that it's running well and if doing all the proactive like support and things like that. So observability is so key for us. Just again, these are kind of the common architecture guiding principles that we go by. Reduce time to value, that's the number one. As I said earlier, we need to ship things faster to production. Everything we do, we build it as APIs. It needs to be secure by design. We also have performance and scalability goals. For example, if you look at the number of customers we have 100 million plus customers. I forget the exact stats, like last 22 plus quarters, we've added every like 1 million every quarter, right? So massive amount of scale. So everything we do has to really scale at that level. And then auto-scaling, again, I'm not going to go through it all, but it just gives you kind of a high-level, picture of some of our guiding principles. And so what happens is, we've made huge platform bets. If you look at, who here was at Brandon and James' talk on, they talked about the platform journey, especially on the on-premises, right? So you can see the amount of investment we've made for like workloads that run on-premises. We have a few examples. We have a PaaS platform built on Cloud Foundry to, for developers to deploy their applications and not have to worry about, the infrastructure, where it runs and things like that. And we've also made major, investments now on running. So if PaaS doesn't work for you, you have option to run it in Kubernetes and container-based workloads. So again, the reason why I'm saying all of this is, especially in the container platform, there's a lot of gaps in terms of really enabling enterprise developers to be successful in deploying their workloads. For example, auto-scaling, scale down to 0. Why would we want to spend if that feature or service is not being used? It's taking resources on the cluster, which, if you scale down to 0, that compute could be useful for other workloads, right? So especially when you're operating in a shared multi-tenant environment, it's really key, right? Cost, from a cost perspective. So point here is, as a platform service provider, there's a lot of investments that we had to make in terms of, and we've been doing it in terms of tooling, not just to keep running the platform and operating on it, but also to enable developers to bring their workloads, right? So for us, when we started talking about Knative, because of a lot of the low-level primitive that Knative's built, we really felt like this could really enhance the platform services that we provide to internal customers. So a bit of a history. I think it was, if I remember correctly, it was back in April that we started talking about. Google team reached out to us and said, hey, we have this thing called Knative. Would be awesome if you guys could, test drive it. So we were like really excited, right? This is a point where we were in the middle of our platform journey. We were investing in tooling and whatnot. So it made really a lot of sense for us to actually, take a look at it, take one of our use cases, actually build something with it and learn from it. And that's what we did. So we picked this use case called Store Locator. So I want to spend some time talking about what this is. The screenshots you see here are from our mobile app. Our customers can actually go and see what stores are nearby, and they can actually go to the store. It could be for things like, I want to upgrade my phone, or I have to go and maybe pay bill, or whatever that is, right? So there's so that's what they use the service for. Currently, this service is actually a big Spring Boot application that built on Java, runs in a container. It's always running. We felt like this is a use case that really fits perfectly with this POC that we wanted to do back in summer. And even if it's something that's we can, even if we put this in, like when we put this in production, right? Even though the platform itself is like really fairly new, we were willing to take the risk of, if something were to go wrong and whatnot. So I'm not sure, I'm assuming everyone's familiar with Knative here, but I just included this slide just for a reference point of view. If you're not familiar with it, there's a lot of information here in terms of community. But at a higher level, there's really three things that we get with Knative. The building, serving, and eventing, right? These are three kind of major pieces of it. Building, the components that make up the building, what that does is it allows us to, as a developer, I have some code in my source control. I want to be able to get that built out and then deploy it onto the cluster. Right? That's what it does at a higher level. It gives us those low-level primitives that helps us get the code out onto the cluster. And then serving, things like traffic management, canary deployments, being able to do blue-green, those kinds of things. Again, you don't want your developers to worry about it. So serving, the components that make up the serving component of it allows us to enable those kinds of scenarios. And then the eventing piece is where we're able to build like really decoupled services that respond to certain actions. Yep. When we first started with Store Locator back in summer, this was kind of the high-level architecture. As you can see here, there's really two kind of components to this. One is the indexing piece, and then there's also a query. So what happens here is we have store data that sits in many different systems. And so we basically feed the indexing service a bunch of, like a CSV file that had all of the stored data that's an export from whatever source. And it would take that file and then puts it into an Elasticsearch index, which is then queryable through the query service, right? And that's the service that our mobile application calls into. This is pretty much the same exact architecture with the current service that's actually running in production, the Spring Boot application. We just simply took that and then just converted into basically serverless, Knative services, right? So this was the original architecture, and there were, as you can see from here, we only used serving components of it. We didn't really use the building and eventing pieces. So it was just a small portion of Knative that we were using. Also, one of the problems here was when we were starting to feed like a file with lots of stored data, it would just time out, especially when it's in scenarios where there's nothing running, and then everything needs to come up, right? So there used to be that cold startup time used to be a problematic scenario, especially the first time. So this is what it looks like now in terms of architecture. So as you can see here, there's pretty much all the components of Knative we're now using. So I want to kind of walk you through from the left side of it, which is basically a CLI that has a command that allows us to load store data into our data set. So so we went. If you remember previously, we were just directly feeding it into Elasticsearch index. So now what we're doing is we're actually pushing all of that data into a BigQuery table. Kind of the reason for doing that is we want to be able to open source that data set. So if someone else wants to leverage the data set and build something off of it, they can do that. And what we're doing as it's actually pushing the data into the BigQuery table, we're also pushing some messages into a PubSub topic. And the reason for this is there's no native integration from BigQuery to PubSub. So we're kind of doing that in the CLI. So, and the other thing to keep in mind here is it's actually also uploading the data in batches. So, so we could really process larger files. And even from an indexing standpoint, because of the eventing, so once the message goes into a topic, then it gets automatically picked up by the eventing infrastructure, which then forwards it to the indexing function, and that's the guy that's responsible for adding it into Elasticsearch index. So we're really able to scale. So as we're feeding more data in chunks, the Knative serving components automatically, the eventing system will pick it up, forward it to our service, and then serving piece of it automatically scales the pod, and additional replicas run, and we can actually really scale and meet the demands, especially processing larger files, which I'm going to show you in a demo. And then the other part, which is the query, there's really no changes. It's just the same exact thing that we did back in the POC. And then the third thing here is the actual building pieces of it, which actually takes the code from the repository and then builds the container image, and then we can now deploy those services. So I'm going to switch to the demo, and what I want to do is I'm going to kind of show you guys right from the build to actually the query and indexing pieces, all of the components. So a couple of things I want to show you here is so we have this repository here called build templates. So I'm sure you've heard by now that the building components there's this notion of build templates, which allows you to compose a set of steps that make up your build process, right? So if we look at this, for example, again, this is just a very basic template that has two steps, right? One is the first thing it's doing here is it's running static code analysis. So we use a service called Sonar to do static code analysis. So I wrote this, I don't know if you guys are familiar with, if you go to Google Cloud Container Builder, so this is, if you go to this repository here, what you see here is these are all of the basically the builders that the community has built. There's also a Google-specific repository that has all the standard supported container images. I built the Sonar builder, and you can actually see it here. So this is what I'm using. So again, the key point here is now we have a mechanism here that we can actually compose our own steps and actually contribute it to the community, and community can also take benefit of it. If you really think about how we do this today, if you're using Jenkins, what we do today is we have shared libraries, right? Whenever there's common steps that everybody's going to need, we create a shared library, but it's very difficult to test. And it's really painful to kind of maintain from a long-term perspective, right? So again, I'm using the same builder that I contributed back to the community from here. So that's the first step. So I run the static code analysis, and then I'm just simply doing a build and push. So it basically builds the container image and then pushes into a container registry. So let me quickly show you how that process works. So before I do that, I have to do one small thing, which is update. So I go to the query, and I'm going to have to, because Sonar I'm using a token. I'm going to actually, obviously I didn't want to check in the token into the GitHub, so that's why I kind of left it there blank. So I have the token saved down here. So I'm going to copy from here, and I'm going to paste it in here. And then I will just go ahead and kick off that. So if I do get builds, I shouldn't really see anything now. So now my build is created. So what happens, so now if I look at the pods running, you'll see a pod running here. If you want to see what the build does, I can just say get builds, and then YAML. So it's actually currently running, so I can just go and see what that build step is doing. So let me copy the pod name as well from here. So you can see now that it's actually running the Sonar scanning process. So it's going to take a little bit, but the interesting thing here is my pod still says it's initializing. If I go back all the way up, it's actually running the build. So there's something kind of funky about the state up here. So if I go back and look, yeah, so now it's actually complete. So if we go back to my Sonar, I should see some analysis reports here, right? It's still, I think the container build is still going on, so build and push. So it takes a little bit of time, but pretty soon we should see an image up here. Again, if we want to see the logs, we can just go, I'm going to go and grab that build container and replace that step. Now it's actually going through that build process. Let's make sure. Yep, it's going to be done pretty soon. Yeah, it's kind of interesting that the status still shows init here. I know last night when I was running, it was actually, it would show like an error here as well. Luckily, it's not showing that now. So obviously, there's options for build this piece to, it's fairly new. There's still, as you can see, in terms of troubleshooting, I still have to, pulling logs from different containers, and so it's not quite in terms of like handing over to a development group. It's really not quite. There's still a lot of tooling that needs to happen, higher level abstraction. But as a platform provider, it's kind of interesting, right? Because we, as I mentioned, if you're running, on a current, Jenkins or whatever solutions you're using. There's a lot of pain points in terms of sharing and things like that. So the model here is so simple that it enables folks to contribute their own specific builders and share it with the greater community, not just the internal as well, but also externally as. Yep, looks like the build's complete. So we should see an image here. There we go. So I can now quickly try to hit that query endpoint. Obviously, right now there's not going to be anything in the index because we haven't really fed any data to it. So if I do a simple query here. Oh, yeah, I think this one. Oh, yeah, actually, I didn't really, at this point, I just built it. I didn't really deploy it. So actually, to deploy it, so if I just go look here, there's the query YAML. So I'm just going to do apply. So that actually will now go. So if we just look at the query, that YAML file, basically it has two things. One is the route, and then the configuration. So I'm actually sending 100% of traffic to my existing version that's running. I mean, you can do things like if you watched all the different Knative demos, you can really have multiple revisions and actually distribute traffic across those revisions. But for now, I'm just going to go with this. So this time, it takes a little while. Let's make sure it's running. Ooh, what happened? It's the build one. Not sure what happened. Anyways, I'm not sure what happened there, but really what you should see there is the pod should come up, and then right now, since we didn't feed any data, it's just showing empty. But let's move on. So the next thing I want to kind of show here is the actual indexing piece, right? So to do that, let me go ahead and, I'm not going to kick the build through the build system. So I'll just come over here and then simply do a build through command line here. So that way we can just do this really fast. Okay, we're just going to let that go, and then I'm going to just kind of jump over back to the slides, just go through a few things here. We'll come back to that in a minute. Oops. So in terms of next steps, what we're hoping to do is we want to open source the data set. We want to actually make the service into a multi-tenant application, and T-Mobile being the first tenant. Every retail customer has this scenario, right? The store finder is something that's pretty common. We want to build web, mobile, and auto experiences on top of it, so you can interact with the service, using any of those mechanisms. We also want to leverage the build pipeline, which right now the build just gets from source to container image. So we want to be able to leverage the entire pipeline so we can actually deploy all the way back down into the cluster. We also want to integrate with the digital assistant. So if you're driving, you can actually do a voice-based interaction with the service. Also, the last thing here is integrating with services like Lyft and Uber. So if you want to, let's say, get directions or drive straight, to the store, you can actually automatically book the, through Lyft or Uber. Just in summary, a couple of things I want to call out is I think we're really excited to see not just the community, developing, but also the partners actually building integrations on top of the platform. So that gives us a choice in terms of if we want to buy third party versus build our own. As a platform service provider, we get a lot of the low-level primitives that we can use to actually build higher-level abstractions and tooling. So we have a choice in terms of build versus buy. And then we think that this is going to be the future in terms of how we build services, cloud-native services. It's been really fun to work on this project with the Google team. It's been, it's amazing to see the community been very responsive in terms of when we run into problems, and especially when we started way back, all we had was basically code. There wasn't documentation, wasn't there, and we didn't really know how things worked. So there was a lot of collaboration with the teams, and we're able to really learn more about the project and build a real use case. Let's go back and see if the build got done. So I'm going to switch to the indexing piece for a minute, and I want to kind of talk through a few things. So what happens here is we feed the data through a CLI, right? We load the data into a BigQuery table. So let me jump over to the CLI and start from there. So this has a command here, load command that what happens here is, let's scroll all the way up here. So this is what gets called when I do load data, and we just make sure the file is valid and all of the other parameters, required parameters like BigQuery table name are all here. And then we parse some data from the config file, and it's actually here, it's actually creating a new BigQuery tape client, and then it will go and create the data set here, create the table if that doesn't exist. And then what happens is we just kind of parse through the CSV and basically break it down into, convert it into a data set that, a type that we understand in terms of store locator, and then we pushes, it will chunk it down here in batches, and then insert row, call the insert row actually, which inserts the rows into the table, and then call the publish message that actually pushes a message into the queue. And I think I'm about running out of time. And the other main piece, I'll make this really quick. The other key piece here is we have, we're using the GCP pub sub source as a way to kind of say, what happens here is, here we're specifying, here's my key, and then credentials to talk to GCP. And then this is the Google project, that's the topic. And then this is the service that whenever there's a message, it forwards it to that service, which is the indexer service that we're looking at. And this has an endpoint here that actually speaks cloud event. So here you can see I'm taking the payload and then converting it back into a cloud event, and then grabbing the pub, basically converting into a pub sub message here. And then from there, I grab the data, which is where my actual store records are, and then that gets then added to the Elasticsearch index. Here it instantiates the proxy and then adds it to the index. So that's how that whole indexing piece is working. Unfortunately, I ran out of time. I'm not going to be able to actually show it working, but all of the code is actually up here in the GitHub. And if you were looking for like real world samples and how to use, you can go to this repository and take a look at. And if you have questions, there's my contact. Reach out to me if there's any questions on the pub sub pieces. Thanks, guys.